Intel Labs is a corporate research and development portion of Intel. We reported to Paul Odolini under the direction of Justin Ratner. We're a worldwide organization of labs engaged with researchers within Intel, academia across the world, lablets across the world. We really look into the future. We work on technologies that we believe will be required to address needs in the future, and we look forward ahead of the business units on what those needs may be to be the leading organization for Intel in research of products. Silicon Photonics is the concept of putting in very small devices optical links which enable data to be moved at very high speeds. The concept of taking optical from the telecom infrastructure, but moving that into form factors that fit into computing devices, from smartphones, small devices, to the data center, up to high-performance computing. Silicon Photonics enables data to be moved long distances at very, very high speeds. The big breakthrough with Silicon Photonics is its small form factor, low power consumption. So we can finally move optics into the platform, thereby enabling user experiences with rich data, a lot of data movement that they've never been able to experience before. And what I have here are the actual Silicon Photonics devices. Over here we have the receiver, over here we have the transmitter. In our first, actually a world's first integrated link, 50 gigabits per second. We made the announcement on this technology. It's a breakthrough in Silicon Photonics. It came out of our photonics technology lab, and we're moving this technology forward for commercialization. Yeah, so you would expect the technology to show up in consumer electronics, so moving data in and out of phones, laptops, portable devices, personal devices. As we have rich content, movies, 3D movies moving around, that would clearly be a way to move them quickly and make the user experience much more compelling. We can use those in the future of television, as television definition goes way up in resolution and in quality and in color depth. Silicon Photonics can enable that technology to become successful. In the data center, you could see this in what's called disaggregating the server or the data center. So you could have linked with photonics elements units of capability, such as racks of computing, racks of memory, racks of I/O. It allows the data center capability to be broken up into much more optimized pieces and into much more granular pieces. So it really allows the architecture of the data center or cloud computing to change in significant ways and really advance. And finally, we see high-performance computing, where there's an obvious bandwidth requirement at the terabit level and beyond, 5 terabit, 10 terabit per second. So to connect high-performance computing elements, to move the data sets associated and the computational load associated with high-performance computing, we finally have something, again, that we can put into the platform to provide extremely high bandwidth at very competitive cost.
Okay, thank you, Jeff.
You're welcome.